All right, guys, another review. Let's go. First four divide, you get to choose. All right, now the first one, you get to choose how you divide, but really you don't on the first one because that x squared right there means you have to do long division. So I'm going to go x squared minus 1 into. Now the good news is if I see an x squared outside and an x cubed inside, it's not going to be very long because there's only so many times you can do this. Like x goes, you need to put an x on top because x squared times x is x cubed. And if I do x times the minus 1 is minus 1x. Now I'm going to put that under the x. Don't put it under the x squared because you can't add those together. Draw the line, change the signs. That's gone. Get negative x squared minus x plus 8. So what do you do to x squared to get negative x squared? Multiply by negative 1. And I get negative 1x squared. And then negative 1 times negative 1 is 1. That goes there. Draw the line, change the signs. That gives me negative x plus 7. And I can't multiply anymore, so my answer, x minus 1 plus negative x plus 7 over x squared minus 1. All you do. Number 2, thank goodness, look at that. I got x minus 2. There's no exponents in there, which means I can do synthetic. The opposite of the 2 goes in your box. I'm going to put those numbers out there, and I'm going pretty quick here. Bring the 1 down. Every time you bring a number down, multiply both in the box. 1 times 2 is 2. Add. 2 times 1 is 2. Add. 2 times 0 is 0. Add. Circle that last number because that's your remainder. Your answer is going to start 1 degree less than we started. We started with x cubed. My answer started with x squared plus x. There's no constant term. I'm going to put the 6 over the x minus 2. There it is. Number 3, one more long division because it's x squared. Now, I'll say this one more time. It's not a really long division because I have an x squared here and an x cubed where I started. Okay, starting at x cubed is not terrible if you have x squared. So what does x squared need to be x cubed? It needs one more x. I'm multiplying that x times the x squared. Same thing I did a second ago. The x times the negative 1 gives you negative x. Draw the line, change the signs. That's gone. That's 2x plus, bring down to 2. X squared goes into x squared 1 time. So I'm doing 1 times everything out there. X squared times 1, negative 1 times 1. Draw the line, change the signs. That's gone. That leaves 2x plus 3 right there. So my quotient and remainder is exactly that. All right, one more division. And luckily, it's x minus 1, so I can do synthetic. The opposite of 1 goes in the negative 1 goes in the box. Write your coefficients out. You're missing an x to the first power, so make sure you put your 0. There'll probably be one on your test tomorrow where you got to remember to put a 0 there, so be careful. Bring the 4 down, multiply, add, multiply, add, multiply, add. And my solution is going to be 4x squared, 2x, 2, and 1 is my remainder over the x minus 1. Okay, I think we're pretty good at that. Number 5 through 7, factor. We got to remember our gesture here for the cubes. Small, big, cube root, square, multiply, change the sign, square. Guys, I don't know what you're going to do if you don't know that gesture, or you just got to memorize the pattern. Sometimes you got to memorize stuff. Hate to say it, and that's one of them. Okay, number 6 is the difference of squares, even though it doesn't look like it. Anytime you have an even exponent, you can take a square root. 81 obviously has a square root, so I'm going to go x squared plus 9. X squared minus 9. Now, look what we got here. We got another difference of squares. That's not, though. That's a sum of squares. You can't factor that, but you can factor the x squared minus 9. Boom. There you have it. Number 7. 4 terms, automatically you're something should go off in your head. Like I'm going to do grouping. Okay, so this first 2, I'm going to take out a 4k squared. That leaves a k minus 4. The second 2, I'm going to take out a 9. That leaves a k minus 4. I'll take out a minus 9. Because I had to get a k minus 4, so that changed the signs for me. So I have a k minus 4, also have a 4k squared minus 9. Now, I would be done except that right there, difference of squares. They both have square roots. There's a minus sign. I'm going 2k plus 3, 2k minus 3, and there it is. Number 8, factor the polynomial given one factor. Because they're going to give me one factor, this one. If that's a factor, that means if you divide it into it, if I put the negative 4 in the box and go 1, 4, 0, don't forget the 0, negative 64, and do this, I got to get a 0 at the end. If it's a factor, it means if you divide it, you do get 0 for remainder. So I'm going to bring the 1 down, multiply, add, multiply, add, multiply, add, multiply. That leaves me this, x cubed minus 64. Same thing we factored a second ago. Small, big, cube root, square, multiply, change the sign, square. And don't forget the first factor. It said factor completely. The first factor is x plus 4, so probably should put x plus 4 along with those, and then you're good. Number 9, just show that it's a factor first and then factor completely. Okay, so it's really the same kind of problem, different language, same kind of problem. Putting negative 7 in here, 1, 0, negative 37, 84. Bring down the 1, multiply, add, multiply, add, multiply. Yep, it's a factor. That's all you got to do to show that it's a factor. Okay, you got 0. That's the first step. First step, see what we have here. I got that. That's an easy factor, I hope. Factors of 12 that give you 7 are 4 and 3. Now, don't forget, I said factor completely. Don't forget your first factor, so I'm going to put the x plus 7 down there with it. Number 10, solve algebraically. This is there's a review now. First of all, factor. That's going to be x minus 7, x plus 4. Draw your little sign graph down here. I'm going to put negative 4 and 7 because those are my zeros. Plug in a hundy. That make that positive and that positive. So that's positive, negative, positive. Remember, the signs alternate. Because it says greater than 0, I'm looking for the plus signs. Where are the plus signs? They are less than the negative 4. And they are also greater than the 7. So there's your answer. Number 10, solve the system using substitutions. What I'm going to do, since it says y equals x plus 5, I'm going to take that x plus 5 right there. It's going in for that y. So it gives me x plus 5 over here, x squared minus x plus 2. You need to start getting in the habit of anytime you see an x squared to think, you know, I need to move everything over. So I'm going to make that side 0. I'm going to move this x over, which gives me a negative x. That gives me negative 2x. Going to move the 5 over. That gives me negative 3. And I'm going to try to factor that. So what factors of 3 or negative 3 give you negative 2, a negative 3, and positive 1? Which that means my x's are 3 and negative 1. Now, that's half the answer. You got to get your y, though. So I got 3 something, negative 1 something. The way you get your y's is you take those right there and plug them right at the top, right where you started. If I take that 3 and plug it in for x, 3 plus 5 is 8. If I take the negative 1 and plug it in for x, negative 1 plus 5 is 4. There you have it. Number 12, solve by complete the square. Don't forget that gesture. Half the middle square, add to both sides. Half the middle square, add to both sides. So first thing you need to do in complete the square is move the 7 over. Okay, if I move that 7, because you got to make space to complete the square. That's going to make that negative 7. That's a 10x. That's not very good. All right, half the middle, half of 10 is 5. Square it is 25. Add it to both sides. Now the right-hand side becomes 18. Left-hand side, we can now factor. Like, what factors of 25 give you 10? Whatever the half was, 5. Instead of writing x plus 5, remember we write x plus 5 squared. That's why it's called completing the square. Now I got to take the square root of both sides to get rid of the square. It gives me x plus 5. Over here, don't forget your plus or minus sign. You can break down 18 with a 9 and a 2. Square root of 9 is 3. That leaves me a 2. One more step and we're done. So take the 5, move it over. And if you move it over, it becomes negative 5 plus or minus 3 on 2. And there you go. Last slide. Number 13 is flat out FOIL, but it's got eyes in it, so be careful. Remember, you cannot leave an I squared in an answer, just saying that. Okay, so first, it's 56. Outer, 84i. Inner, negative 32i. Last, negative 48i squared. That I squared, remember, is really negative 1, which makes that negative 48 become positive 48. So I'm really looking at a positive 48 right there, which I'm going to add to that 56. Everybody knows 56 and 48 is like 104. And then I can combine those two terms in the middle. 84 minus 32i, 52i. There you have it. Two more. 14. 14, first of all, I got to subtract 8 from all three sides. I'm trying to isolate that x. It's a negative x, though, so be careful with that. 6 minus 8 is negative 2. Now, to make a negative x become positive x, I'm really about to divide all three sides by negative 1. Don't forget, when you divide by negative, you flip the signs. So I get that right there. So my answer is between greater than negative 10 and less than 2. You can write that like this in your brackets. It's brackets because there are equal signs there. All right, and the last one, number 15. 15, we got a 3-variable system. It says use your calculator. So I'm flat out going R ref, and I'm hoping you remember how to do that. I'm going to punch that in. I can't really show you that on the video, but go to second matrix, matrix A, add it 3 by 4, punch in all your coefficients, all the numbers, quit. Remember to go to quit, go back to matrix, go to math on top, scroll up to RF, hit enter. Then you gotta go back to matrix one more time till to do matrix A. This is the answer I'm getting. Remember your answer's on the last column when you do that. You should get -7, -4, -2. Now if you just know the steps, that's a gimme. All right, so hope that helps. Hope you do great tomorrow. I think you will. Let's have some great scores. See you tomorrow.